Welcome to this tutorial on asymmetric encryption with OpenSSL. Today we will demonstrate how two users, Alice and Bob, can securely exchange messages using public and private keys. Unlike symmetric encryption, which uses one key for both encryption and decryption, asymmetric encryption uses two keys: a public key for encryption, which can be shared openly, and a private key for decryption, which must be kept secret. This ensures that even if the encrypted message is intercepted, only the person with the private key can decrypt it. Let's move to our hands-on lab. Bob, the recipient, must first generate an RSA key pair, and I'll be using OpenSSL command, which I'll start with OpenSSL generate private key, so that will generate a private key, and then the algorithm RSA. This specifies that we are creating an RSA key, and this will be saved as bob_private.pem. So this is the private key that will be saved as bob_private.pem, and then this followed in the command with public key opt RSA key gen bits 2048. This will create a 2048-bit key, which is the recommended size for secure encryption. The private key now, if I hit enter, is Bob's secret key. The private key is Bob's secret key. It must never be shared. Let me clear so I can start on top again, and here what I need to do, I verify that the key was created. So I'll do ls, and then for details the -l, and then bob_private. I need to check the private key if it's created, so I can see that's created, it's available. And then I will review the private key content using the cat command, and I'll do bob_private.pem. So this should show the private key for Bob. In a real world scenario, this should be private, so should not be shared. Just for demonstration, I'm showing you the private key so you can see it. So here where the private key starts, and here where the private key ends, as you see. Now that Bob has the private key, we need to extract the corresponding public key, which Alice will use to encrypt the message. So for Alice to encrypt the message, what we need to do, we need to extract the public key, and then Bob will send the public key to Alice. As we said, the public key can be shared. To create the public key, we'll use OpenSSL. I'm using RSA. I want RSA or OpenSSL to get into the bob_private.pem and extract the public out and save it as bob_public.pem. Now if I hit enter, writing RSA key, let's do ls just to verify the key is there. Now I have both private and the public keys. So this is the public, it's there. Let's use the cat to view the public key. I'll do bob_the public key, and then here we go. Here where the public key begins, and here where the public key ends. That's the public key, which could be shared openly with everyone that needs to communicate with Bob. We did verify that the public key was created, and we did view the public key. Now what Bob needs to do, need to send or share this public key securely with Alice. This can be done via email, SCP, or any secure method. What we'll do here, we'll use SCP just to demonstrate that the key is being shared. To do this, I'll use SCP, and here I'm sending Bob public key, and I'm sending this to Alice. And here, this is the IP address of Alice's virtual machine that will be using the public key to encrypt the message and then send it to Bob. So here, this is the SCP command like we did in previous videos, and then if I hit enter, it will ask me to authenticate, so I need to key in the password, and here we go. The public key is now shared with Alice. Now I'm on Alice virtual machine. So now Alice will write plain text message to send to Bob, and this will be saved in a file called message.txt. So what Alice will do, will write the message using the echo command. So it says, hello Bob, this is confidential message, and this will be saved in a file called message.txt. So this is what Alice will do first, but Alice wants to encrypt this. To encrypt this, Alice will use Bob's public key, so that only Bob with his private key can decrypt it. Alice uses the following commands. So we are using OpenSSL. So what I'll do, I'll use OpenSSL, the public key utility, to encrypt. So the dash encrypt specifies encryption mode, and then we have the dash pub in. This indicates that we are using public key for encryption, and then in key bob_public.pem, this specifies the public key file to be used. So I'm using Bob's public key to encrypt the message, and what I want to encrypt is in message.txt, and the output will be saved in message.enc. So the message.enc, this will be the encrypted file. Let's hit enter and see if this command works. That was successful. Let's verify that the encrypted file was created using the ls. So I'll do ls-l message.enc, and now the message is securely encrypted. Even if someone intercepts message.enc, they cannot read it without Bob's private key. Alice now wants to securely transfer the message, this encrypted message, to Bob. To do this, we'll use the same protocol, SCP, and what Alice will do, will send the message.enc to Bob's machine. And this is the command. I put the IP address of Bob's machine. It will ask me to authenticate. I'll type the password. I'm using Kali VMs, so that's why the username in this case Kali, and the password is Kali, as downloaded from the kali.org website. And here we go, 100%. That means the encrypted message is now transferred to Bob. Now Bob will decrypt the message using his private key with this command. I'm still using OpenSSL, so I'll type OpenSSL, and then I'm using the public key utility. So I'll use the public key utility to decrypt in this case. So let's have a look at this command. So OpenSSL, I'm using the public key utility, but this time I want to decrypt. So this specifies the decryption mode, and then what I want to provide Bob's private key. So in key, this will use Bob's private key to decrypt the message. As we know in asymmetric, just one more time, a message will be encrypted with the recipient's public key, which was shared openly with everyone, and only the recipient's private key will be able to decrypt the message. So that's why Bob here in this scenario will be decrypting the message with his private key, and this is only private to Bob, so only Bob knows this private key. And then what I want to decrypt is message.enc. This is what we received from Alice, and then the output will be in a file called decrypted.txt. Now if I hit enter, and then I'll verify as usual, ls-l, and this time I will verify the decrypted. If I use the tab key, I should get the file name, and then here we go, the decrypted.txt is available. I want just to make sure that I got the message, so let me just use the cat command to view the content of decrypted.txt, and here we go. Hello Bob, this is confidential message. So Bob was able to decrypt the message that was encrypted by Alice using Bob's public key. Bob successfully, as you see here, decrypts the message. This proves that only Bob, who possesses the private key, can read this encrypted message. Unlike symmetric encryption, where both Alice and Bob must share the same key, asymmetric encryption eliminates the risk of key interception. This technique is widely used in secure web communications using SSL TLS, pretty good privacy email encryption, and SSH authentication and digital signatures. That completes our demo on asymmetric encryption with OpenSSL. We successfully generated an RSA key pair, encrypted the message with the public key, and decrypted the message with the private key. Like, comment, and subscribe. Stay tuned for more cybersecurity videos.